Okay, I'm going to work through an example for each of a cylinder and a cone. Starting with the cylinder. This happens to be number 26 on your worksheet if you want to follow along. I've already got the formulas there. Recall that we derive the formulas from the formulas that we have for a prism, and we're looking at a cylinder as a prism with circular bases. So you really don't need to memorize these formulas specifically. This is the most direct way to calculate it, but you could, of course, start with something like recognizing that this is really my perimeter of my base, and therefore perimeter times height turns into circumference times height. 2 pi r is my circumference formula. Same thing when we get over here. This is really my base area, and you see the base area again here. So just keep that in mind if you struggle with memorizing formulas, that you don't have to memorize these specific formulas. I'm going to go ahead and work on plugging in. So let's grab what we know about our cylinder, and in this example we're given that the diameter is 20 millimeters. So I'm going to attempt to put that on here. And then the height is 2 millimeters. So when we're plugging in, that's all I'm going to do is go ahead and plug in everything I know. We're going to put in a 2 for the height. Of course, the radius is going to be half the diameter, so that's going to be 10. And the 2 pi r, or the 2 pi, is going to be just from my formula. So I end up with 2 times pi times 10 times 2. And I'm going to multiply all of that out. So I'm going to keep it in exact form. It's going to be in terms of pi. 2 times 10 is 20, times another 2 is going to be 40 pi. For my units, let's go ahead and do millimeters squared. Lateral area. When I get to surface area, of course, that is going to be part of my answer. So I'm going to have 40 pi. And then I'm going to calculate the base area but multiply it by 2. So plus 2 times pi times my radius is going to go in there. Radius squared this time. Multiplying that out, 10 squared is 100 times 2. I'm going to get plus 200 pi. And of course I have 40 pi that I'm adding to that, giving me 240 pi. These are like terms because they both have the pi, so I can go ahead and add them. 240 pi millimeters squared. My pen doesn't want to write that small. Millimeters squared for my total surface area. And last calculation we need to be able to do is volume. Pi r squared times height. So putting in a 10 for my radius, height of 2. Multiplying that by pi, giving me 100 times 2, which is 200 pi. And of course, this time it's millimeters cubed, since I'm talking volume. And you can go ahead and use the base area that you calculated for the surface area, or just recalculate it. Okay, that's as tough as it gets for the cylinder. There's no finding any measurement other than the fact that if you're given the diameter, you're going to have to divide by 2 to get the radius. Let's take a look at a cone. So here's my cone. Again, I put the formulas there, and you can recall that we can recognize that this is really my base area there that I'm adding. This is my 1/3 base area times height. Same relationship between a cone and a cylinder as there is between a pyramid and a prism. It's 1/3 of the volume. And the lateral area formula, you have to do a little bit more to derive that if you're going to try to derive it, and I showed you that in class. So I'm going to skip that part. Let's look at an example. This is 29 that we're going to do from your worksheet. You're given a height of 4 centimeters. So let's go ahead and draw in the height there. That would be straight down the middle as best as you can do to the middle of the base, and of course perpendicular at that point. And that is 4 centimeters. And the slant height is 6 centimeters. Let's grab, I'll use purple for that. If you can see that. And a good old 6. Whoops. 6 centimeters for that. So the first thing I'm going to do is just start plugging in and see what do I know. And I know that there's a pi there in my formula. Radius. Uh-oh, I don't know the radius. Slant height, I do know. Slant height is 6. So I'm going to have pi times something times 6, but I'm stuck because I don't know what the radius is. So I'm going to go back in here and draw the radius, and I'm going to recognize that I have my all-time favorite shape. I have a good old right triangle going on here, and you guessed it, Pythagorean Theorem to the rescue. So let's go ahead and draw in my right angle there. And this is just my little side calculation to look for the radius. I'm going to be doing 4 squared plus r squared equal to 6 squared. Just pretend you can read those little 2's that I'm trying to write. And we're going to do 16 plus radius squared equal to 36. So I'm getting radical 20 for my radius. Of course, that simplifies to 2 radical 5. So coming back over to here, I'm going to put in a 2 radical 5 is what I just calculated for my radius. And this is going to be your favorite answer of the entire day. We get to have 12 radical 5 times pi, radical and pi in the same answer. We can't simplify it any more than that. You are done. Put some units with it, of course. And that's my lateral area. So, that gets to go in here. 12 radical 5 pi plus pi times radius 2 radical 5 squared. So remember, if we're squaring that, we're squaring both parts. 2 squared is a 4. Radical 5 squared is 5. So that's going to give me 4 times 5, or 20 pi when I come down here. So I have 12 radical 5 pi plus 20 pi. Not like terms, you're going to have to leave it like that. If we hadn't had a radiate or a radical, we could have combined our pi terms just like we did in the last example. Last one, I've got volume, 1/3 pi times radius squared. Again, 2 radical 5 squared times my height was 4. And I'm going to try to squeeze that in. 2 radical 5 squared was 20. So I've got 20 times 4 gives me 80 pi over 3. 80 is not divisible by 3. I'm going to end up with a fraction. You know I hate mixed numbers, so I'm going to leave it just like that as an improper fraction, centimeters cubed, and my volume is done. So there you have it. That's your cone. Good news, the cone is easier, hopefully you agree, than the pyramid. You're never going to end up with more than one triangle. You always have that same right triangle that we saw, and you will just have to make sure whatever you're given, you're going to be given 2 of the 3 things, and you're going to be looking for the other. So I could give you the slant height and the radius, and you could have to find the height. But it's the same triangle. Just make sure you know which one the hypotenuse is. Okay? Good luck. Work through some more of those on your own.